Hello again. So this video or this module is a continuation of our previous module where we were trying to implement an R code for K-means algorithm for the using the market segmentation or the using the social media profiles of the teens population. So in the last module we were talking about how we can identify the gender information by creating those two variables. So now that we have taken care of the missing values for the gender variable, let's go back to the age variable and try to impute the mean age value to those records with the missing age information. This three data over here is sort of an optional. It's I just put it here so that you can play around it. So if you look at this command over here, what it does, it will not really work. If you run this command, it will not really work, and the reason for that is because when you just try to run the mean command for the age variable, the reason it will not work is because the age variable has a lot of missing records. So that's the reason it will not work. However, if you add the command of na.rm, which is do not consider the na values equals to true, then this will work. You see this? So if you remove the na variable, if you do not consider the na variables, then the mean age population or the mean age for the given population is 17 years, 25 or 2 months, 17 years to 0.25 months. And however, using this command, which is aggregating the population or aggregating the age by the graduation year, which is what you have done, and that is age as a as a function of the graduation year. Take the mean value and na.rm equals to true, that is do not consider the na values. So if you run this command, you will see the mean age data for each graduation year. So for 2006, the average age is 18.6 years. For 2007, it's 17.7. For 2008, it is 16.7, and for 2009, it's 15.8. However, to using this aggregate command and trying to merge it with our merge it with our existing data set can be a little tedious task. So R has this function called average, which is denoted by AVE in R. So we can use this command and merge it with our existing data set. So you can run this command over here. And what we will be doing is, because we want to impute the mean age value to those records where there is a missing record, where there is an na value. So what we will do is we'll add the if-else function to this command. So that's exactly what we are doing it over here. So anytime there is an na value or missing record for the age column, imputed by the average age value. So that's exactly what we did over here. So if you run the summary command, I need to run this first. Okay. So now if you run the summary command, you will see that previously we were getting this na number of na values, but now that you have imputed the missing values with the mean age values, we will now get that the first quartile value, the minimum value, the max age value, and the missing record or the na column will now disappear because we have imputed the missing values with the mean age value. So now that we have taken care of the missing values for both the age and the gender information, because we created this additional columns for the gender, that is the female column and the no gender column. Remember this? Remember these two columns over here, no gender and female. So we have created, or we have done the dummy coding for the age, for the gender, and for the missing age value or the missing age record, we have imputed it with the mean age value. So now that we have taken care of both the missing values for both the gender and the age, we'll now get started with our training data set. So so this over here, what we have done is we have excluded the first four variables. And the reason we have excluded the first four variables is because the first four variables includes the information on graduation year, gender, age, friends. So we don't really want to include this, include this uh, variables in our clustering. And the reason for that is because we want to classify the clusters based on their interest group and not really the age or the gender. So to do that, what we did is we created this another variable called interest and assigned only the, only those variables that do not include or that do not have the, gender or age information. And after we have done that, we will normalize the data. And the reason we normalize the data is because if you take a look at this data, you'll see that some of the variables are 1, some of the variables are 3, and if you take a deeper look into the data sets, you will see that some of the values are 11, 12, 13. So there is a huge difference between, or the huge gap between the minimum value and the max value. So when we are doing data analysis, it is always recommended that we standardize or normalize the data so that the mean value of those data is always 0 and the standard deviation is always 1. So so that way it helps us to it helps us to do better analysis when we standardize the data, and that will sort of bring the data to sort of the same curve range. So once we so that's exactly what we are doing here with this function as dot data frame lapply interest scale. So scale is the command by which we are standardizing the data. And after we have done that, we will set the seed function to 2, 3, 4, 5. This value over here can be any other number, but I just put it 2, 3, 4, 5. It can be 2, 3, 50, any other number. And the reason we set the seed function to certain specific values is because it ensures that the random number generated is always the same regardless of how many times you run that iteration. So that's exactly what we did here with this function. So once we have done that, the next step that we'll be doing is run the k-means algorithm for the standardized data, which is stored in this variable interest underscore z. And for this function, or for this k-means algorithm, I have assigned the k value as 5, meaning that I said that I would like to categorize or classify the data points into 5 different clusters. This again is up to you. You can give it as 3 clusters, 4 clusters, any number that you want. But in the given case, I just give it a value of 5. So now that I've done that, let's take a look at the cluster size. So we see that for the first cluster there are 1038 data points, 601 for the second, 4066 for the third, 2696 for the fourth, and 21599 for the fifth. So let's take a look at the centroid, or the center of these clusters, and see how they have been classified. For now, given that there are many uh, okay, so for now we know that there are many variables that we took into consideration to classify or many variables that we considered as a point of interest for the given data points. Let's just take a look at the first 4 columns. Okay, let me just clean this up and rerun it again. So if you take a look at those first 4 columns, that is basketball, football, soccer, football, you will see that the first cluster over here, they seem to have relatively good amount of interest in the sports. But if you take a look at the fourth cluster, you will see that these fourth cluster, they seem to have higher value for, for each of these sports category, which means that fourth cluster, or fourth cluster seem to have, seem to have people gathered, or seem to have clustered people with more interest in sports. And because these values are z-score standardized, or have been z-score normalized, positive values above the overall mean level for the teens, and negative values are below the overall mean. So higher the value, higher the amount of interest that these teenage people have for that given category. And if it's if it's a lower value, that it means that they have a lower interest for that, for that variable of interest. So once we have done that, we can also take a look at other variables. So let's take a look at the first 10 columns of interest. So okay, I will get back to the fifth cluster a little later, but if you take a look at this, maybe we should look at more cluster centers. Let's take a look at the first 15 variables. So I just chose the first 15 variables. You can take a look at the entire 36 variables. So if you look at this value, or this values that we have spitted out, you will see that the value for cheerleading for this third cluster is a bit higher, and it's got like lower values for the soccer and everything else, and it's got the higher value for cute, likewise higher value for hot. So maybe this is a group of cheerleaders, or like that. Interestingly, if you look at cluster 5, you'll see that most of the values for the cluster 5 is negative. And if you remember, this is also the cluster which has the highest number of data points. Remember, we had around like in 21,500 something number of data points for the cluster 5. So the reason for the negative value is quite interesting for cluster 5. And the reason for that could be that, maybe it's, maybe the users the users belonging to this cluster 5 created the profile on the website, but they never really posted any interest in the group. So that could be a possible explanation for cluster 5, because they seem to have negative value for for almost every variables of interest that we have spit it out so far. You can look at the other remaining variables, but so far, considering the first 15 variables, given that the value is negative for the cluster 5, it could be a reason that these people, they created their profile in the social media site, but they never really posted any anything of their interest in the social media. So once we have done that, let's apply the cluster IDs to our clusters. So yeah, so that is one way to cluster our data points. So if you take a look at the first 5 records of our data set, and we are just trying to know their the cluster they belong to, their gender information, their age, and friends. So we will see that the cluster 5, he is a male, and the age is 18.9, and he's got 7 friends. So this person belongs to the cluster 5. And likewise, if you see another record who belongs to cluster 5, he is again a male. The age is 18.335, and that person has 69 friends. So you can take a look at other variables of interest, and see what and see if the cluster information that we have gathered so far is correct. But that is basically how we cluster the data using the k-means, and using this data we can target specific market ad campaigns to the population.